guys, since we're not doing lengths yet, that goes next chapter and the next one beyond that. Since like this chapter's been mostly focusing with, let's see, you had parallel lines and you had things like that's 100 degrees. So is that you've been just working with angle measures. This is just going to take the stuff that we would have already done with the parallel lines and maybe turn it into a triangle or apply things within the triangle. So all we're focusing on now is going to be the interior angles and then exterior angles. Interior angles meaning this one, that one, and that one. If I took all those angles and added them together, do you know how many degrees they make?
180.
190. Okay. 180. So this is technically, I think, a theorem. This would be your interior angle theorem for triangles. Just saying, if you wanted to write it out in actual words, in a triangle, interiors, that doesn't make any sense. A base sum of 180. Okay? Meaning that I could give you two of the numbers. You can find the other one by just subtracting them from 180. I could put variables on each one of them. If you've got to solve for variables, you would just add them up, set equal 180. This is going to give you the equation for what you're working with within a specific triangle. It's not always going to be ABC. So just because this says ABC, guys, doesn't mean every triangle is going to be ABC either. Okay? So if X there, that's about 85 degrees. This is like 30. You said solve for X. This would be probably the most basic problem you can do in terms of interior angles of a triangle. I'm giving you the two numbers. The other one is X. There's nothing else to divide by with here. It's just X by itself. And then find the third angle. So if I wrote this out as a full equation, it should be that. What's 85 plus 30? 85 plus 30. I just want that step first.
It's 125. Wait.
Who said 125?
8 plus 3 is 11.
Wait, no.
5 on the end.
I was about to say that.
And then if you subtract that, I think someone already said it was 65. Okay. To make these, let's say, a little bit more involved, should I use X again or a different letter?
H.
H?
Yeah.
Alright, this will be 2H. Be say H plus 10, and this will be
H minus 5.
4H minus 5. There you go.
Excellent.
Okay? So a question like this would say something like, solve for H and find measure of all angles. Okay? Yeah, how do you do it? You like Adam. Okay, if I like Adam, what do you get?
You do like 1H minus 5 plus 2H plus H plus 10 equals 180.
Okay, so 7H.
Minus 5.
Plus, you even
Plus 5. I
You get the
meant that. Ugh.
H is what?
25.
Yeah? Yeah? You just guessed? Does it really work?
Yeah.
This is awesome.
Nice.
I think it works.
Okay? Hey, even if this comes out to be a decimal, guys, you still got to go through the act of plugging them in. And hey, get in the habit of, if you get a decimal answer,
35.
gosh, if you get a decimal answer like on a test, on the test review stuff tomorrow, doesn't mean you did it wrong. Because like decimals and fractions, you'd use all the time. So if I plug those in, this should be 50, right? This is 35. Correct? Didn't
Yes.
screw us up. And that should be 95.
Yes.
All right, next thing. Okay, exterior angles. When we're dealing with shapes in here, polygons, and they bring up exterior angles, the way these are formed is you're taking the side of whatever the shape is, and right now you're working with the triangles. And you just take that side and extend it out. When you extend it out, that would be the exterior angle they're referencing. There are going to be, I guess, a couple, well, really one main theorem that comes from this. I'll put a 3 out there. The 1, 2, and 3 are just numbering the angles to make the equation I can write out easier. There's an exterior angle theorem that says that if you take one side like of a triangle, extend it out, form an exterior angle. To get this measure without doing a lot of work, I can take these two numbers and add them together, and they will always equal whatever this angle is at here. So this is what the exterior angle theorem says. It says if you know these two, which if you read the theorem in the book, these things are called the remote interior angles. So they're the interior angles that are not right next to the exterior. If you add them up, that'll always be equal to the one on the outside. This is not a necessary theorem for solving out the problems. Okay? Because you know this aspect over here where they add up inside to 180. Meaning, if I knew these numbers here, I could also find this angle, and then this angle here, and this one right next to it create a linear pair, which is something you already know. Those are two things you definitely have to know. This is like a shortcut if you can remember it. Okay? So if I had give me a number here. Two, something for an angle.
16.
21's all right, and then what? 16?
5.
Sure, 16. Fine. Okay?
57.
Like if I was doing this problem, and considering I just talked about the theorem, I would probably do this the shortcut way. My x here is on the exterior, and if I could remember it down the line, most people do not actually remember this theorem just because we do it in passing and for this one day. But if you can remember it, a quick way to get this number is you just do 21 plus 16, which is, what's 21 plus 16? 30 what? 37. Okay? So that's 37. This is not, like I said, the only way, because you also understand that this angle here, the 16, the 21, and this angle right here should all add up to 180. So if you want to go about it the long way, but the way that everyone should be able to do it, you can do 180 minus the 21 minus 16, right? Subtracting both of those from 180 to get 143. So this would be 143. And like I said, these two angles right here create a linear pair. And everyone should be to a point where they're going a linear pair adds up to 180. So if I know this one, I can subtract that number from 180 and take you back to 37. That's the roundabout way to do it. This is the shortcut. That's the way everyone should be able to do it. Okay? If you forgot it, right, this is how you find slope. You have to have two coordinates. You subtract the y coordinates on top. You subtract the x coordinates on the bottom. So if you subtract the x coordinates, you get a 0 down here. It's undefined, which means it's a vertical line. If you subtract the y coordinates and you get a 0 up here, but you have a number down there, that's a slope of 0, which is your horizontal lines. Anything else should give you a number. The order for what they have these here, y2 and y1, honestly, it doesn't matter. The thing you have to remember when you're doing the subtraction to keep the sign correct is the coordinates you're working with kind of need to be stacked. Like these two, this x and y would represent one point, that x and y represent another. For like formula purposes, they put the 2 and 1 there, but you can simply remember this as subtract the y's and subtract the x's, and then you divide them. You just got to make sure the order you subtract them in stays the same. Because if not, then you'll have an incorrect sign with it. Like you'll have a negative slope where it should be positive just because you flip-flopped one of the subtraction things. So you already said, slope is the same. So when the slope is the same, that was what, parallel? Technically, what this should be, if you want to really write this out, it should be slope is the same. Y-intercept is different. The y-intercept be the same, it'd just be the same line. And when you said slope opposite. I'm going to give you an example slope, and I'm going to see what you mean by opposite. So let's say my first slope, right? And remember, the letter m, the lowercase m, is just like the general thing they use for slope. If I gave you that one, what do you mean by opposite? Yeah, okay. So you have the right idea. Okay. So 5/4. So if I saw these two, that would mean the lines are perpendicular. Okay. So this is called, when you flip a fraction, that's called a reciprocal. So usually this gets called as like opposite reciprocal, or sometimes like negative reciprocal. Just meaning that the opposite is dealing with the sign. So the signs have to be one positive, one negative. And reciprocal meaning they just have to be flips of each other. So one side's 4/5, the other one's 5/4. Or if you had one that was like, if your original slope was -2, and you wanted to do one that was perpendicular, the one that's perpendicular is +1/2. Because this is technically 2/1, so if you flip that, it becomes the 1/2. So testing for you guys, this would be like that 7th way that's on the sheet for showing that lines are parallel. What'd you say? Say it louder. If you're wrong, you're wrong. It's not a big deal. Yes, very good. That is 1. Okay. This would be probably the one that sticks into most people's heads. This is not the only form of a line in terms of writing these out. This form is called slope-intercept. Right? And it's called slope-intercept form because it's formed with the m there, right? And m always represents what the slope is. And this chunk right here, well, not the plus, just the b. This represents what the y-intercept was, right? And y-intercept, remember, just means where it crosses the y-axis. Okay? The only other form you really need to be familiar with is point slope form. When I do the problems up here that are going to be writing the equation line, this is what I'll use because most other classes are going to use this form. All right? Point slope form is written like this. The m right there, that's still your slope. X1 and Y1 is a point on the line. Okay, so like for this one to actually work when you're going to use it, you have to either know enough information to get the slope, meaning they're already going to tell it to you, or they'll give you 2 points to find it. And they also have to tell you within the problem, if you're writing a line, that they tell you a point that's on it. If they don't give you this information, you're probably not going to use this form. If they don't give you a point that's on the line, it's probably going to reference back to this. Also, y-intercepts, guys, just for a note, if they say something like, write the equation of a line, and this point is on the line, and the point they give you is of the form 0, something. This number right here, whatever they put, that is the y-intercept. So if they give you a point and that first number is 0, that's telling you what the y-intercept is. Okay, it's just giving it to you in another form. again, the way I'm going to approach this is the same like 3 steps that I just had up there. The question says, write the equation of line. Like that's the first thing it's saying. So that means that since I have to write the equation of line, I'm either going to start it using that form or this form. Now again, I'm only doing it the way that I feel is the best. If you can do it another way and you're good at it, do it that way. I don't really care. As long as the final outcome is the same, then that's all that really is going to matter. After I see what I'm aiming for, like this is my equation of line, I'm working towards one of these two. Step 1 would be, I need to know what the slope is. Did they tell you what the slope is here? What is it? 2? Fine. Step 1 done. I didn't have to do any work. They told me what it was. Second thing. Do I have the y-intercept? What is it? So 0, 3, which means if it's given to you in this form, remember that number is the one that I'm using for B. So this would be an easy one because the slope and the y-intercept are right there. You don't have to do any work. And really, even if you're doing work, your only work that you'd have to do is in this portion right here. Okay? Because now since I have slope and I have y-intercept, I'm using this form. Okay, you could use this one because this is technically a point. It just looks weird to have a -0 somewhere. Okay, so this formula would look like 2x plus 3. That's the whole thing. Just from me plugging in the m and the b. That's what I need first. Do they tell me the slope of the line? Like, do they flat out say the slope of the line you're writing or something like that? Like the last one said the slope of the line is, right?
Yeah.
Does this one say the slope of the line is? No, what's it say?
Says
What is that? What?
slope 3x is the slope.
3x is the slope?
Well, 3 is
What do you mean?
over 1.
Because y equals 3x minus 2x.
So that number right there is the slope. But this number, that's the slope of this line. Yes? Okay. That doesn't necessarily mean it's the exact same slope I'm going to use. But the other word that they have up there with that is going to lead you to how to apply this. Meaning they should probably tell you parallel or perpendicular here. Does it tell you parallel or perpendicular? Parallel. So since it's parallel, that means that, right, slopes are equal. So if this line has a slope of 3, the line I'm about to write better have a slope of 3, or else they're not going to be parallel to each other. First step done. Second step. Do they tell me the y-intercept of the line I'm working with? Not the one that's over there. I don't care about this line anymore. The only thing I need from this line is the slope. All right? Once I'm done with the slope, once I take that out, I forget that thing even exists. So for the problem that I'm working with, like the line I'm writing, do they actually say, here's the y-intercept of it? No. So I don't want that. So that means I'm probably not going to do mx plus b form. Do they give me a point that's on it? What is it? 2, 4? Okay. So for like, if I match it up to point slope form, that acts as x1, that acts as y1. Okay? So I'm done with that. I got those first two. So now I'm just taking this and I'm plugging it into what point slope was. All right? Y1 I've listed as 4, so that's where my 4 goes. M we said was 3 because it's parallel. And the 2 is that. So I got everything plugged in. The only other thing I would have to do is if it says write it in a specific form. Does it specify any form up there? Does it say write this in slope-intercept form? Then I'm done. Like that's it. You can stop. It's fine. I didn't specify a form. You're good to go. Okay. Again, same checks. Equation of a line. First thing is I need to figure out the slope of the line I'm writing. Okay? Just like the last one, this problem should not flat out say the slope is a certain number. But they give you an equation of a line, correct? Did they give you an equation up there? What is it?
Y equals 1/4 x minus 8.
Minus 8, okay? Again, the only thing I care about in this line is that number. Like this could be minus 8 billion, it doesn't matter, okay? This is all I care about. Because this number right here tells me the slope of that line. Which again, now I'm going to take that and use it to find the slope of the new one because this new one has to be perpendicular to it. Okay? And perpendicular just means you take this number, you flip it, change the sign. Okay? So again, keep that in mind, guys. If they put a number out, like an equation, this is all you need to work with. This part, just forget it's even there. So for 2, do they give me a y-intercept to go through? Yes or no? Do they give me a y-intercept or a point? Point. So that's gone. So what's the point? And what? 9. Okay. So again, in terms of point slope, that's like x1 and y1. All right. So I've got my slope. I got my point. That is all I need. That changes to a plus because point slope form is set up as x minus what the x coordinate is, so the two negatives combine to make that a plus. It doesn't say specific form, I don't think, so I can stop right there and be completely done.